Okay. All right, ladies, Ruby, thank you. So, if we're open to 3B, my plan today, we should definitely get 3B done, and maybe we can have a little bit of a look at 3C. 3C is a big fat exercise, and it takes a long time to get through, so it might be good if we can sort of have a preemptive strike on it today. So definitely function notation today. Hopefully we've come across it before, where we see f and then in brackets x, and you will also see pop up in the textbook this sort of weird notation. We never use that apart from it popping up in the textbook. It means the same thing. It means a function of x. And you can think of it like it's a machine that you put an x value into and then out pops a y value. Okay, it's a function machine. You put some number in and then out pops a corresponding y value. Now we're looking specifically at this type of function as well, when we have things at the top and things at the bottom. And we know the top of the fraction, that's called the numerator, and the bottom, that's called the denominator. Okay, the numerator and the denominator. And in your notes, it's got written there that this function will equal 0 when the numerator is 0. Okay, so the numerator here is x take 2, so the function will equal 0 when the numerator is 0. And when the denominator is 0, the function is undefined, righty? That's because we can't divide by 0, right? We remember that. Okay, so let's have a look at our first example here then. So we have f of x is x squared plus 3x plus 2, and it's divided by x take 2. Okay, that's our function. Part A, find f of 0. Now, all this means is we're putting the number 0 into the function machine. So everywhere there's an x, we're going to put 0. So we're going to have 0 squared plus 3 times 0 plus 2 divided by 0 take 2. So I'm going to write all of that out. But you can just envisage everything with an x, that's 0, that's 0. So at the top we're left with 2, and at the bottom we're going to be left with minus 2. So that simplifies to minus 1. Okay, so this is a function machine. When you input an x value, out comes the y value. So when we input x is 0, all right, we're putting in x is 0, then the corresponding y value is minus 1. When x is 0, y is minus 1. That's the coordinate on the graph. Okay, part B. Find f of 1. All right, f of 1. Now we're going to put the number 1 into our function machine. So we're going to put 1 everywhere there's an x. So we'll have 1 squared plus 3 times 1 plus 2 divided by 1 take 2. And then we'll go through and simplify this. So at the top, I've got 1 plus 3 plus 2. That's going to be 6 at the top and minus 1 at the bottom. It simplifies to minus 6. We have, when x is positive 1, the y value is minus 6. All right? So y and f of x, you'll use those interchangeably. They basically mean the same thing. Okay? But we will use both. You will see both pop up. Okay, part C. Find f of minus 1. All right, now we're putting the number minus 1 into our function machine. So we're going to have here minus 1 squared. All right, so that has to go in brackets because we're squaring the minus 1. Then we have plus 3 lots of minus 1. And then we're dividing it by minus 1 take 2. And we'll simplify. Sorry, I'm missing the plus 2 there, aren't I? There we go. There's our plus 2. Now, minus 1 squared is positive 1. 3 times minus 1 is minus 3. And we'll leave plus 2 there for now. And at the bottom, we've got minus 1, take away 2, that'll be minus 3. All right, so all we're doing is simplifying. 1 take away 3, that's going to be minus 2. Minus 2 plus 2 is 0. we have 0 at the top and minus 3 at the bottom. What is 0 divided by minus 3? 0, okay? So 0 cakes divided by any number of people is always going to be 0. The only thing we can't do is have a denominator of 0. That's when it's undefined, right? So what this means, when x is minus 1, the y value is 0. Alright, so they're the corresponding y values. Okay, for what values of x is f of x undefined? So here's our function. It is going to be undefined when the denominator is 0, right? We can't divide by 0. We've got that written up here, okay? Undefined when the denominator is 0. So let's make that argument for part D. F of x is undefined when the denominator is 0. Now, our denominator for this function machine, this particular case, the denominator is x take away 2. So it's undefined when x take 2 equals 0. So now if we solve that equation, how do we get x by itself? We're going to plus 2 to both sides. We have it is undefined when the x value is equal to 2. Alright? If we put the number 2 into our function machine, at the bottom we're going to have 2 take away 2. That's going to be 0. We're going to have a 0 in the denominator, which means the function machine is undefined when x is 2. Alright, so that's where we have a vertical asymptote, that dotted line occurring that we looked at last lesson. Okay, part E. Now, we're doing a little bit of a foreshadowing here. It's a skill that you have learned before, but we're also, it won't pop up in this unit, but I'm going to go through this part anyway. It says, when is the function, for what values of x is f of x 0? For what values of x is the y value 0? So here's our function, and we're saying what makes this function equal to 0? Top of the notes it says, for a composite function like this, it's going to equal 0 when the numerator is 0 and undefined when the denominator is 0. So we're looking at the numerator for the function for this question, the particular case, and we're saying, so let's make the argument again, f of x is 0 when the numerator is 0. And in this circumstance, our numerator is x squared plus 3x plus 2. All right. Does anyone remember what kind of equation is this? Starts with a Q. Quadratic. This is a quadratic equation. All right. So the way we solve this equation, we're looking for two numbers that have a product of 2. When we multiply them together, we get 2. And when we add them together, we get 3. Okay? So we're looking for two numbers that multiply together to get 2. And when we add them together, we get 3. So those numbers are going to be 2 and 1, isn't it? 2 times 1 is 2. 2 plus 1 is 3. So that means our factors, x plus 2 and x plus 1, we can factorize this quadratic into 2 linear factors. Okay. So all we've done is we've moved from there to there via factorization. Now let me stress, that skill that I've just done there won't pop up in this unit. All right, we're just exploring it now. It's definitely part of the last unit, and you have done it last year, yeah? Everyone remember factorizing quadratics? Okay, good. All right, so I'm just touching on it for now. It's just showing you that's how we can factorize the top. If we were to expand this using FOIL and collect like terms, that's what we would end up with. So we haven't changed this value. We've just presented it in a different way. All right? And now if we solve that equation, we would apply the null factor law. We would have x plus 2 is 0, or x plus 1 is 0, and we get our two solutions. All right? So they're the values of x that make the function equal to 0. And interestingly, we already had one of those pop up, didn't we, in part C? We saw when we put x is minus 1 in, what happens to the function? the function comes out as 0. All right, so we saw that in part C. In part E here, we're asked to find both of those values or find all of them. We already knew one of them was -1, but we've demonstrated it here through the factorisation process. All right, so again, just to emphasize this skill, don't be alarmed if you're like, I don't remember how to do that. It will pop up in the next unit. For now, we're just looking at substituting the numbers in, finding the corresponding y values, and then later on, finding when it's undefined and when it's equal to 0. Okay, just using those properties at the top.
Where do you
So,
get that 1 from in the, like, where it says 2 from a 1? Where's the 1 from? Yeah.
there?
Yeah, where's the 1 from?
So, when we're so this is the skill that's going to pop up in the next unit. Do you remember that's a quadratic? And we're looking for two numbers that multiply together to give us +2.
Oh, yeah.
And when we add them together, we get 3. So 2 times 1 gives us 2. 2 plus 1 gives us 3. Yeah, good question. But